So how does temperature affect suction lift? Well, do you remember I said earlier that liquids give off water vapour at all temperatures? So if you've got a liquid and you've got we'll call it a partial vacuum, you've got some vapour being given off. Temperature will affect this. This is because the vapour pressure increases with a rise in temperature. Now, the boiling point is when the vapour pressure is the same as atmospheric pressure. So if you heat up water in a cup or in any way you like, you heat water up to its boiling point, that is when the vapour pressure, water vapour pressure of the liquid is the same as atmospheric pressure, and it will just boil off. So that's the principle. Clearly, at this temperature, any suction lift will be negligible, and therefore water would not be able to be raised because they'd have nowhere to go. You can't evacuate because all the water vapour is taking the place of the air, and there's no air being evacuated for it allowed to be going. So at that temperature, at boiling point, you can't lift anything. That's the rule. You can't lift anything. Now this chart shows you the effect of temperature on suction lift. As you can see here, the maximum lift possible at 5 degrees C is approximately 8 metres. The maximum lift possible at 40 degrees C is 7 metres. Now the maximum lift quickly drops off at higher temperatures. At 70 degrees C it's 4 metres, and 80 degrees C it's 2 metres. Any higher and it's virtually zero. Do you understand how temperature can affect? So you do not want that water to get hot, and that's the principle of not allowing pumps to get hotter and hotter and hotter, because if the water gets hotter and hotter and hotter, you can't lift the water. Very important fact. Very important fact. So don't forget, I said, as you reduce pressure, you reduce the boiling point of a liquid. So as you reduce the pressure above a liquid, you reduce the boiling point of that liquid. In other words, if you boil a kettle at sea level, the water boils at approximately, we all know, 100 degrees C. What happens if you took that kettle onto Mount Everest and tried to boil that kettle? Well, I can tell you now, at about 30 degrees C, that water would boil. Why? Because you've reduced the pressure in the kettle, pressure above the water in the kettle, the water will boil at a lot lower temperatures. That's why they say you can never have a good cup of tea on Mount Everest. You can't have a good cup of tea on there, because you're up there with your little fire, you put it on there and the water's boiling. You go, oh, water's boiled, I'll have a cup of tea. But that's cold. It's at 30 degrees. Why? Because it's boiling at 30 degrees. Why? Because up there there's not as much pressure. Don't forget, pressure is the head. It's all the air above it. On Mount Everest there's not a big column of air. You come down here and it is. Now if you boil the same kettle in a cave located at half a mile down, the boiling point of water will be about 160 degrees. It'll be boiling hot. Do you understand? The boiling point depends on the pressure. And this is the principle of a pressure cooker. If you can increase the pressure above the liquid will boil at a higher temperature. The principle of a pressure cooker is, if they increase the pressure above the liquid to say 200 bar, whatever pressure they increase it to, it increases the boiling point of the water. So the water's boiling at a lot higher temperature. And that's the principle of a kettle. Going back to this, what would happen if you made a flask of tea at coffee at sea level? So I make a flask of coffee at sea level, I come with flask in, take it up, and I take it up, it's a solid flask, rock hard, solid flask, but I boil my kettle, the water's boiling, and I quickly take it up to Mount Everest, and I open the lid. What's going to happen to my coffee? Do you know what's going to happen? It's going to boil off. It's going to literally just vaporise. Why? Because the boiling point of water up there is 30 degrees, and that might be at 70 degrees. What's going to happen is it's just going to boil off straight away. Your flask would literally empty immediately. And it was solid, you just open it up, and all the coffee would just boil out of there. Now, reducing the pressure above a liquid, as I said, not only reduces the boiling point, but it increases the amount of vapour which is released at the surface. Now, this principle can cause issues for the fire service when trying to raise water and pump it. So when they're carrying out suction from a river or something like that to get water to flow, this can cause real problems. The most widely used pump by the fire service is a centrifugal pump. And its very principle is water enters an impeller. The impeller speeds it up and it throws the water out. Centrifugal pump throws the water out to the outer kit, which increases its velocity. So it gives it velocity energy, and then this velocity energy is turned into pressure energy. And then what happens is, so the pump imparts initially velocity energy to the water, then it changes it in the casing back to pressure energy. It gives it pressure at the valve, and then when you get to flow, it flows, and when it gets to a nozzle, it converts this pressure energy by reducing the cross-sectional area into kinetic energy to allow it to flow. Do you understand what it does? That's the principle of the centrifugal pump.